All right, what I'm looking at here is I've set up that simple interest in Excel that we set up last time, but I decided that I would put in $22,095, that magic number for someone to put away for 40 years to be a millionaire if they can get 10% interest. I've now set this up in such a way that this first one, all right, the first column is just going to count up by ones and count what year number you're in. $22,095 is what they put in as their starting balance. Over here, what I've done is, if you can see, you can't see it right there, but it says take $3 and multiply it by 10%. $3 is the C column and the third row. Multiply that by 10%. The $sign on the 3 means keep going back to that C3. Keep going back and get your interest at 22,095 times 10%. And if you look at the interest column, they're always the same. It's 1/10 of that. It's $2,209.50 every year is what it's paid. And you get to see what the end balance is and how that works out for the person. By getting that much money every year, at the end of their 40 years, total they have $110,475. So that's probably not too bad. They could have collected that money every year and spent it, or they could have just let it build up. But if you're going to let it build up, you should go for compound interest. So what I'm going to do is I'm going to take everything that they did for their 40 years and I'm going to copy it. And I'm just going to place it over here where I'm going to deal with compound interest. And compound interest is looking exactly the same now, so that's not accurate. What I'm going to do is I'm going to go here where it said $3, which meant keep going back to row 3, and I'm going to remove the $sign from it. Now it just says G3, which means go to row G3, which is saying go to the one right next to me and get 10% of that. And it's going to be exactly the same right now because nothing has happened over the years. But what I'm about to do now is I'm going to take that change and I'm going to push it all the way down for the 40 years. And now we're going to see what that did. What had happened is, now instead of being 22,095 like it was in the very first year without any compounding, this one was 22,0950 in the second year, and this one was $2,430.45. So in the first year already, it's making about $220 extra. And yet that gets more and more intense as time goes and the years pile on to each other. Imagine this. First year's money is going to get paid interest for 28 more years as part of the cycle. Second year is for 27 and so forth. It's going to go ahead and do that. So there is an impact. You don't see it in the first year, but we do see it over time. And then we look for the growth, the effect of the growth of that. So let's look at what they did. This person right here earned $110,475 at the end of 40 years. So I'm going to go in this other column and look for something that's like $110,475. I actually beat it by a few dollars. $111,678. Got there in 17 years. So here you are, you're 22. Does it seem like waiting 17 years is a long time, and so does waiting 40 years seem like a long time? But if you're in it for the long haul, for the 40 years, let's look at what happens at the end of the 40 years. Because you might be thinking, oh man, Knossos just wants us to save, so he's lying to us. And the thing is, all this did was apply that arithmetic time and time again. They used to do this by hand. They had accountants do this by hand at 10% and 9%, and make these big books of ledgers and all that kind of stuff. And now the calculator, that is this computer, can do it for us. If we look at what happens at the end of the 40th year, $110,475 go to the person who had simple interest, but the person with the compound interest got $1 million as well as $3.25. $1 million got reached by putting that amount of money in. So I won't be offended if you think that I lied to you because I think these young kids should be saving. Well, okay, let me tell you. All we have to do is I can create this document in about 3 minutes notice, or I can send you a copy of it. So I'll save it here if someone wants a copy of it to look at more closely. Just send me an email and say, can I get a copy of the simple and compound interest for 40 years? And the thing about it is you can control how much money you put in at the start. If you only have, instead of $22,000, what if you only have $2,000 to do? Does that work? Well, I'll put $2,000 in simple and I'll put $2,000 in there. So you got about 1/10 as much, actually 1/11 as much, but still it's something. So we're going to put that in there, and it starts with the $2,000 and sees, what about if I just put $2,000? Maybe I do have $2,000. Well, if you do it with simple interest, it turns into 10,000. If you do it with compound interest, it turns into 90,518 and 51 cents. So you may be interested in that. But my point is, if you thought I was lying and you get hold of this, your job would be to find the year where I put in the fake number to make it look like saving is a good idea, when really all I do is not want you guys to have lattes and avocado toast or go to the movies or stuff like that. I'm not out to kill your fun. I'm here to explain compound interest and say that's what the numbers do, is that 22 grand put away right now will be $1 million. How about if 2 grand goes away, it'll be 90 grand when you're 62. That's why you got to get in early. And so I just wanted to point it out like this and offer that I'll send this to anyone that requests it. I'm going to save it on my computer and I can fire it off to you at any time. You can change the numbers in there, but it does the job. So hopefully some of you will be interested enough in it and maybe even do a project on it. All right, I'll talk to you soon. So now I have that same spreadsheet working here, and I've made a yellow line where we're at 10 years and a yellow line when we're at 40 years. And 40 years reached the $1 million compound. It only reached 110,000 if we did simple. But then I had done another calculation in the lecture that said if you put in $385,543, $543. So that's 385,543. That after 10 years, you would be right around $1 million, which is right there. So what that shows is that if you only do this savings plan for 10 years instead of 40, you actually do have to put in $385,543 to get up to just about $1 million. $999,999.25 to be precise with that. And if you'd started with that amount and did simple interest, it would make it up to $771,000. So it's very important to start early. So that's all I wanted to show right now with this. And remember, you can ask me to send you this file. It'll be no problem. I'll be able to forward it to you through email. Okay.